Okay, so good morning, good afternoon, and good evening, everyone. Thank you for coming to this session. I'm Ariel Huang from Bayer, US. Today, I would like to show to you a full picture by using innovative software tools for data insight generation. Not quite sure whether you have worked in the clinical trials, but in the clinical trials, when the study is finalized, we have to generate or review a lot of tables, listings, and figures for the planned analysis and also for ad hoc analysis. This is usually time consuming, and even for the reviewing, it also would spend a lot of efforts and time. Sometimes something could also be overlooked. And we're always thinking whether there is a better way of handle this kind of work and review. As a famous saying goes, a picture is worth 1,000 tables. Here is the way. Although tables, listings, and figures is still the standard approach, especially for planned analysis without any doubt, it has some limitations. For example, it only provides static outcomes. The generation and review of the tables, listings, and figures is very time consuming. And sometimes something could be overlooked by only reviewing those static outcomes. Luckily, now we have another option that is an renovative approach, which is the interactive data visualization apps. Unlike these traditional tables, listings, and figures, the graph created here with data visualization apps are not limited by the size or the static nature of the paper format. The visualizations would allow the reviewers to zoom in into individual patient profiles, and also the dynamic graphs would encourage a faster understanding and more lively discussions of the data. It even allowed to follow up immediately on new ideas or questions during the review meetings. And most of the cases, it would be possible to get an answer in the same meeting. In this way, the time-consuming loops of post-hoc analysis requests could be avoided. Moreover, it is interactive. So the team members are now switching from the passive part, which only reads the outputs. Now they're in the active parts. They could together play with the data. In all, this method provides us an effective way to understand the study data. So in Bayer, we have developed several data visualization apps. Today, in this talk, I would like to introduce some of them. All apps presented in this talk are standalone programs. They are developed with R or R Shiny and can be used on any computer on which R is installed. The only requirement of using them is that the data to be analyzed is in an appropriate format. Without further ado, I would like to first introduce to you the app to support efficacy analysis that is called Subgroup Explorer. It simplifies the identification of outcome-relevant subgroups. It helps answer questions such as, are there subgroups in the data of a fair study which ruin the overall result? Or are there subgroups in phase 2 that might enrich phase 3 studies? This is a screenshot of the main feature. Long story short, this app calculates the endpoint outcome in each subgroup and subgroup combination and plot them into this figure. The y-axis represents the outcome and the x-axis represents the total number of subjects in each subgroups. If you click on a dot, This dot would be highlighted in red, and the information, the result of this subgroup, will be provided in the table that is below the graph. In this way, you can easily identify any outcome-relevant subgroups. You could also filter a specific subgroup level. For example, here we are interested in age larger than 65 years old. After I select this filter, all related subgroups that has the factor age larger than 65 years old will be highlighted in green, and the information of these subgroups will be presented in the filter subgroups table below the graph. The next apps I would like to introduce support safety analysis. The first one is called ADPRO. It is short for Animation of Adverse Event Profiles, and it helps answer questions such as, are there differences in the type of AEs between treatments or between subgroups? Other questions such like, are there differences in the time of onset, duration, or severity of specific events between treatments? Here is a screenshot of this app. Each circle in the figure represents one subject. They are sorted and separated by treatment groups. You could select up to 8 adverse events. Each event is symboled as different colored and as a slice in the circle. The severity of AEs is represented by the size of the slice. On top of the figure, there is a bar, signifies the number of studies in the number of days in the study. You can move the slider to any numbers represents any days, or when you click the play button below, the app will automatically play the individual AE profile from day 1 to the last day of the study. So the user, which means you, can interactively view the appearance and disappearance of AEs either day by day or dynamically like a video from the first to the last day of the study. It is a pity that due to the time limits, I could not show you the animation of this app, but you could find the YouTube video at the reference page. In a word, these apps enable a faster and more detailed insight in AE appearances in clinical trials. With this one, you can also choose the animation speed. I hope I have more time to introduce each app in details, but I have to move on. The second app I would like to introduce that support safety analysis is called Elaborator. It provides insight into lab data with evolution over time and help answer questions such as how to detect changes in liver function parameters across study visits and explore whether changes differ between treatments. There are also questions that could be answered, such as, are there frequent time causes in a lab parameter described through increases or decreases between 2 subsequent study visits? Here is an example of the output. This is the quantitative change analysis. It provides the box plot for each lab parameter per visit. For example, here is the box plot for the parameter HbA1c. The dots in the plot represent each patient, and the reference ranges are visualized. Then when we zoom out for a small subset, we have such graph. Each column is one lab parameter. Each row is one treatment group. Green means the values of parameter decreases through the study, and yellow means the opposite direction. Then, when we further zooming out for the complete data set, we can have a better overview of all the parameters of the study. There is also unsupervised learning using for seriation of lab parameters. The third apps that we'd like to introduce that support safety analysis is called Detector. It provides general early safety signal identification and AE monitoring. It helps answer questions such as, are there any unknown safety signals? Which adverse event drive the difference in the incidence of adverse events? Let's see the main functions of detector, that is the double dot plot. This is a combination of double dot plot. Here, each incidence proportion is represented as either single dot or triangle. And they also have the arrow bars that show the effort and 95% confidence interval. Last but not the least, it also provides the adjusted and unadjusted p-values that help you identify any potential interested features. Then we have another app to support benefit risk assessments that is called BREZ. It helps assess the benefit risk assessment with forest plots and value trees. And it helps answer questions such as how is the benefit risk profile overall and in subgroups. This is one of this figure called forest plot. In this plot, the estimates of all relevant efficacy and safety outcomes can be shown in one graph and is separated by efficacy and safety. After reviewing the results of both efficacy and safety, we could also generate the value tree, where the green represents benefits and red represents risks. Taken together, our current set of those apps covers all key aspects of a study, including adverse events, lab data, and efficacy and safety outcomes, both efficacy risk assessment and the subgroup analysis. Last but not the least, I would like to emphasize how this app can together benefit our clinical study. This is in a collaboration way between the operational and clinical functions. Imagine that we have a half-day meeting where the clinical leads, medical experts, regulatory affairs, statisticians, data management, and more all come together to investigate the efficacy and safety profile of a study when the study comes to an end. A meeting like this is where we share our insights based on our diverse backgrounds. So in such a meeting, if we utilize these apps to provide a deeper and more detailed data insight of these clinical results, we will surely to bring this review meeting to a new high level. So this is my presentation today to introduce to you several data visualization apps that are developed in Bayer. This is the reference for the apps. Most of them are open resources that you can find in either GitHub or CRAN. And also would like to thank all the colleagues that support the development and maintainment of these apps. Thank you.
Thank you so much. I know we don't have any questions yet in the Q&A, but I guess I'd love to talk about, like, you always been passionate about data visualization? Like, did you kind of set out to work on this kind of stuff?
What do you mean?
Well, have you made a lot of these interactive tools? I guess my question is, have you always been interested in that, or is that just the way your path has gone?
No, this is a specific group in Bayer. that we developed this kind of apps specifically for our clinical study. So it's not my personal effort, but it's a team effort. But I'm been very interested in such of the apps because it helped a better understanding on the data and the results, even for statisticians and non-statisticians.
Definitely.
Mm-hmm.
I guess a follow-up question.
Yeah,
I've never
sure.
developed an app that's been used probably as much as these or at
Yeah.
all. Do you ever solicit feedback from the people working on the trials who are using it? Maybe potential like things they'd like to see added or improvements?
Yes. Actually, the apps are open resource that we publish in our CRAN and GitHub. And we'll also deliver some presentation to introduce these apps to a bigger population. And we receive feedback from our colleagues in other companies that they use these apps indeed in their work. Definitely not the planned analysis, but they use them in data exploration, even when they would like to explore the data for any regulatory requests, questions. So these apps help provide a better review and insight of the data and support them for a better answer, for an good answer to the request.
Really cool. Thank you.
Yeah, thank you.
I have a couple more minutes if anybody else has any questions. Well, if not, let's thank our speaker and we can take a couple minutes to shift gears for the next session. But thank you so much for
Thank
kicking us
you.
off. Yeah.
Thank you. Okay, bye.
Bye.